it's important to get an idea of what the graphs of logarithms look like. And we've already said that the log function is the inverse of raising to the power. So let's put both of them on the same graph, and we'll start so let's just look at y equals 10 to the power of x. And from previous work, we know that this function here will look a little bit like this. And you will know that when x is equal to 0, anything raised to the power of 0 is 1, so it's going to go through the point 1 there. The inverse function of y equals 10 to the power of x is y equals log to base 10 of x. So this will map x to the point 10 to the power of x and then log x to base 10. Now normally, as I've said before, if it's log to base 10, we just don't put the 10 there and we just put log of x. So both of those mean exactly the same. Okay, so what's that going to look like? That'll look like this, where it goes through the point 1 there, because the log of 1, so when x is equal to 1, the log of 1, now don't forget the log is an index. What's the index you've got to raise 10 to get 1? And that's 0, so that's why y is equal to 0 when x is equal to 1. So this is y equals 10 to the power of x, and this one here is y equals log of x to base 10, or just simply log of x. And we've talked before about inverse functions being a reflection in y equals x, and so if we were to actually put in y equals x, it would go like that. You can see that this is basically a reflection. Logarithms also are only ever defined for positive bases, and logarithm, the log of a number, simply goes like that. Alright, so that's y equals 10 to the x. We just move down a little bit. We can now look at y equals e to the x. And it'll look very similar. Don't forget, e is a number 2.71828, and here we've got 10, so e is pretty close to 3, so it's going to look a little bit like y equals 3 to the x. Once again, it'll go through 1. It'll never cut that x-axis there. So there's y equals 3 to the power of x. And the inverse of that is y equals log to base e of x, which is also sometimes written as ln, natural log of x. You don't have to put the e there because ln is log to base e. So once again, these two are just two different ways of writing the same thing. And what will this look like? Once again, if this is the point 1 up there, it is going to go through the point 1 there. And it'll go like that. So very similar to what's happened up above. And once again, if we look at what y equals x, you can see that one is the reflection of the other, indicating that they are inverses of each other. So we should put y equals x up there as well. So both graphs are fairly similar, and you can get the idea of what's going on.